Hi, I'm George Runkle with Runkle Consulting Incorporated, and what we're going to do today is we're going to talk about a house that we've opened up the inside significantly. I'm going to let David Moore, who's the contractor, Structures Incorporated, narrate exactly what we did, and we'll pass it on to David. And this was quite an extensive residential job. I think you'll agree as you take a look at, and it presented a number of engineering challenges, which David will highlight. And I hope you enjoy the video. All right, we're recording.
Hi, this is David with Structures. What we've done with this house, where I'm standing right now, this used to be a chimney where it steps out right here. It went from here to here. There were 2x6 walls running all the way around, because when we look up, we can see where the chimney chase is. You see the flues going up above this upper roof. There is a brick chimney that's approximately 5 foot by 5 foot square that goes up about 15 feet above that roof line. So there's a tremendous amount of weight up there. So what we did, they wanted this basement to be more open all the way around, like it is right now. And there used to be walls here. There was also, if we come this way, there was a wall right here, and then a wall on the other side over there, going back that direction where the rebar, where the concrete is lower. There were walls all the way around that. So what we did to start with is we came in here, we cut our joist back, put hangers on it because there's a 2x6 wall right here, and we put this beam up. Now this beam is a triple LVL with 2 pieces of 3/8 inch steel plate 16 inches deep in it, running approximately 16 feet across, supported on with the 4x4 post on both sides. The thing that we did with it, if you walk over this way, you can see we've got a 4x4 or 5x5 plate on the top, and it might be hard to see in the video, but up the side there is a steel plate running all the way up it and bolted to it that way. There you go, you can see it right there. That way it's helping to stabilize it. Even though it's attached to the decking up top, we won't get any kind of rotation, which is what's really important for us. If we look off to our left right here, we actually removed another wall right here. You can see we put another beam up here. So we've actually removed 4 structural walls in the basement of this house. The one over there was kind of the same. It's set up here. Again, the joists were coming in perpendicular to it, so we put hangers on all the joists, attached it to the beam. This one has 4 LVLs and 2 plates holding it up. All of these are 16 inches deep. So all of these are structural load-bearing walls from the couple stories up above. Let's go back out here to where we get to the really big ones, because compared to those, these are small. What we did right here, we go up the ladder, this is the inside of the chimney. It has 4 LVLs, 3 plates of 3/8 inch steel. Over here we have a matching one. These are 16 inches deep. These are going up approximately a little over 16 foot wide or long, and they are holding up everything up above. That's the chimney, the wall, the fireplace. Everything's going to be held up by this. And this is the back of the house, so there's a tremendous amount of weight up there. So as we walk out this way, we can look and see this beam came over, the 16-footer comes over and rests on the middle of this post. So there's a second one coming from here all the way over to this post, and that's one continuous one that's a little over, about 12 foot long. And so it's supported on this end, the steel post. It's supported on this side with a half the post, and then we put a post here, and we have the 2 beams running underneath it to help hold up the second beam here and then also helping to support everything along here. And it gives us a nice pretty look as we come down the stairs. We come in, it's nice and open and clean and gives you a really pretty line as you're walking down. And there'll be a door on the back wall which is going to be built, and that's all brand new because that was all exterior, a covered porch inside here, which is now all becoming inside part of the house. We are putting a floor across upstairs, so you're getting additional space inside here. You're also getting all that additional space in the first main floor of the house. So we're increasing the size of the house just a tremendous amount without changing the footprint or the roof line, which made a big difference. Then after we put this beam in, we came over and they wanted this wall right here removed. So right here you can see there was all right where the offset is, because this was exterior, the lower section. This was the interior on this side. So we got a wall here, and it is 4 LVLs and 1 3/8" plate. And you can see it was holding up the windows. What's going to end up happening is where you see this window cased up there, we're opening it down at the bottom, and that's going to become a walk through a cased opening to come out into the new room upstairs. Also on this side over here, the fireplace will be reinstalled, and both windows on each side are coming out, and that's going to become a walkway also. So you can transfer, so you can walk all the way around the see-through fireplace that we're putting up there. The fireplace will be visible on both sides, so that'll give a really nice look to the side here. Also, the inside over here, the ceiling is up about 20 foot high from this upper beam. So when you walk from there, and even this side over here where the window is has a higher ceiling, this ceiling becomes a low ceiling in the house, even though it's 10 foot high. So what we're doing is we're coming into the middle of this ceiling, which is a relatively flat, low ceiling. It's a metal roof on top. We're putting a hole through it. We're building 8 foot in diameter, an octagonal shaped cupola. So that's going to go up in the air, approximately another 7 feet higher than that. We'll have 8 windows all the way around it. That'll allow all the sunlight to come in and give the place a feel of a lot more open, airy feeling. And that's, let's look and talk about the beams a little bit and the post, because one of our concerns is rotation. Obviously, we're setting all these beams in here. We've got some beams stacked on top of other beams. We wanted to make sure that this thing would never rotate, because if it rotated, there's a possibility that, you know, we've got it sitting like this, then there could be failure. Failure in this case would mean death. I mean, people would die if this thing collapsed on us. So we have to be really, really sure that we're doing it right. And that's the most important thing, is always to do it the right way. We don't cut corners when we're doing this type of work, because it could be death. Seriously, that's not just a joke. That's something that could happen. And so this is not for the inexperienced person. I mean, I'm talking through this. It all worked beautifully. It worked beautifully because we've done this for 20 years. We know what we're doing. We know how to remove walls and hold up the rest of the house while we're removing a wall underneath it, not let it fall on our heads. So, you know, if you're having this type of work done on your house, make sure you get somebody that knows what they're doing. That is really, really serious. So as we welded up the poles, we started with the plates in the bottom, anchored it to the concrete, welded it all the way around. We go to the top of the post right here, it's welded around the top of the post. Then when you get up top, we've got pieces going up both sides, and that is bolted all the way through. So you can see the 4 bolts that are there. You're not going to have any kind of issue with that piece coming loose. Let me pull this ladder over back here, and I can point out what I'm talking about a little bit easier. So, stay on this side.
Okay.
Okay, so we welded around here. We have our plate coming this way, going up both sides. It's welded all the way along here. So now we have a nice U-shaped saddle that's going all the way up. We ran this triangle out here because this is a separate piece, and what we wanted to do is make sure that it's fully supported, even though it's being held up by this wood also, the LVLs. It's welded across the top there. This plate runs across this way. This plate goes up, it's welded there. These two places are bolted to both of these beams, and again, we're making that nice L so there's no chance of movement occurring. And it's fully bolted. It's welded all the way up. So we have really good welds there. The same thing's happening on this side. But also one other thing you'll notice is along here where we have this 16-inch deep 3/8 piece of steel, we actually put welds on each one of those pieces just to fully connect all of this metal with the metal that's inside our flitch plates. So basically what it gives us is it gives us a fully supported area where no movement can occur. And that's what's really, really important, is that we keep everything straight and strong, and basically it just all stays up in the air.
Yeah.
Which is what we want.
Okay. Thank you, David.
You're welcome.